Okay, good morning. Welcome to the class. So today we'll talk about another topic about counting. So we will talk about combination and permutation. So I believe some of you have already studied this topic in your high school, but never mind. There will be something new from today's class. And for those who haven't heard of this topic, then you don't need to worry because we are going to talk about this from scratch, so from zero. So you don't need to have any background to understand things. So these two words are mathematician that use to describe two common operations we use daily. Okay, so for combination, we are actually talking about selecting things. So combination is about selection. And then permutation is about arrangement. So I'll give you some example. Okay, so for instance, let's say we have 5 people, A, B, C, D, E, and then we want to select two persons from these five people. So in that case, this will be a combination problem. And then maybe we are interested in how many different kinds of combinations that we can form. How many ways that we can select 2 persons from these 5 people. Is that okay? So this is a combination problem. So there could be another problem like suppose we have 7 books and then we want to have these 7 books arranged in a line. So book 1, book 2, book 3. So there are 7 books here to arrange in this way. So we want to ask how many different ways can we arrange the books. So for instance, 1, 2, 3, 4, 5, 6, 7 is one way. And then 7, 6, 5, 4, 3, 2, 1 is another way. 1, 3, 5, 7, 2, 4, 6 is another way. So how many different ways that we can arrange the book? It is a permutation problem. Is that okay? So today's topic is about combination and permutation. And we are going to count how many different ways we can form a combination and how many different ways we can form a permutation. Is that okay? Oh, good. So some very simple terminology that I want to describe. So let's take a look. Suppose that, okay, I'm using this to group many people. So let's say there are 5 people, A, B, C, D, E. We talk about selecting 2 people from this group. Maybe we are going to select A and B. So this represents a selection of this A and B. So we can select any other 2 persons like CD. CD is a different kind of selection. Is that okay? And then AC is another kind of selection. Is that okay? And BA. Okay, for BA, we don't consider it as a different selection from AB because what we are interested in is who are the persons that we are selecting. Okay, so the order of them doesn't matter. So this one will be equal to this one. So we are saying that these 2 are equal. Is that okay? And then normally we want to ask how many different kinds of combination we can form, and each of these combination has 2 persons inside. So we call every one of them a 2 combination. Is that okay? These 2 describe how many items we are selecting from this whole group. So this is a 2 combination. Is that okay? The original 5 person that we have, you can say it is a 5 combination because it has 5 people inside. Is that okay? So the number here corresponds to how many items are there in your combination. So this is a 2 combination. This is another 2 combination. This is another 2 combination. Is that okay? Okay. Okay. Similarly, let's say we have the same objects A, B, C, D, E. So, and this time, let us say the ordering of the items is important. Okay, so if you so we want to select, let's say this time 4 items from this group, 4 items from this group, and then make an arrangement to them. So one possible arrangement is, one possible way of selecting and arranging is, let's say this is A, B, C, D. This is one possible arrangement by selecting 4 items. Is that okay? Okay, we can also have B, C, A, D. This is another arrangement. Is that okay? And then we can select different kinds of 4 items. Maybe I'm selecting B, C, D, E. This is another arrangement by selecting 4 items. Is that okay? So we call each of them a permutation, and each of these permutation has 4 items inside. So we give it a name. So we call each of them a 4 permutation. Is that okay? So this permutation describes that the arrangement of items is important, and this 4 describes that how many items are there inside. Okay? Okay, good. Okay, now 2 more notations we can talk about real things. So I'm going to use this one. So we are interested in counting problems, counting how many ways to select, how many ways to arrange. We are going to use this symbol C, N, R. This one is defined. I define it to be the number of, okay, so the number of R combination from a collection of N items. Is that okay? So we have N items in total, and we want to ask how many ways can we select our items from it. So this is the notation CNR it stands for. So the C is for combination. So similarly, we will define PNR. So this is a notation. This is for definition. This is going to be the number of R permutation from a collection of N items. Okay, so PNR is counting something different. PNR counts R permutation, which means that how many ways can we select R things from N items and then make arrangement to them. So how many different arrangements that we can form when we select our items and then arrange them. Is that okay? Good, 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 good. Okay, so we can now test our understanding. Okay. So this is the definition we should bear in mind. So each one of them is a number. So let's see if you can tell me what is the value of CNN. What is meant by CNN? So CNN is number of N combination from N items. So how many ways can we select N things from N things? 1. Very good. Yeah, because we have to choose everything. Is that okay? And how about this CN1? What is it? N. Very good. So this is N. And then C. Okay, so this one we have not tried this, but C32. What is C32? C32 is we have 3 things in total. How many ways of selecting 2 things from them? 3. Okay, so we can select AB, we can select BC, we can select AC. Good, three ways. And then, how about P32? Now this is about permutation. So ordering also matters. So we select AB, let's say. So AB will be counted differently as BA. So they should be 2 cases. 6, is that okay? So it turns out that there are 3 ways here. But for each way, there are two possible ways to arrange them. So we select two items from it. So let's say we select AB, then we can arrange it in AB, the natural way, or in the reverse way, BA. Okay, so it is equal to 3 times 2, so it is 6. Is that okay? Okay, so far we don't have any formula of computing this. We are only reasoning the value of each of these terms by common sense, okay, by counting in our brain, okay. Now, next, we still don't have any formula yet, but I want you to tell me why is the following formulas, why is the following equalities true. So the first one is this one, CNR. I'm saying that, okay, it is always equal to, always, no matter what n, what r you have, it is always equal to Cn n minus r. We don't have any formula. Of course, if you know the formula, you can plug in the values and then check that the left-hand side is equal to the right-hand side. But we don't have any formula. So we have to argue. We have to argue that these two should be the same. Okay, so the left-hand side is how many ways to select r things from n items. The right-hand side is how many ways to select n minus r things from n items. So why are the number of cases in these two different selection the same? Why? So you have n items, right? Okay. Why is it true? Any idea? Anyone? Anyone? Any idea?
在取，假设你从 n 里面取 r 的时候，那你等于是看作是这边取 r 的，那你剩下也等于是有点类似说把剩下那些 n 减 r 的取出来，那怎么样？
好 ，very good, excellent. So his solution is perfect. So here, the number of ways to select r things to put in my bag is exactly the number of ways to select n minus r things to throw away. Okay. Each time when you are thinking of selecting r things, it is like I'm selecting n minus r things to throw away. Okay? Is that okay? So we call it, there is a one-to-one correspondence, one-to-one mapping from this selection into this selection. Whenever you can come up with a way of selecting r things, you can come up with another way of selecting n minus r things. But they are doing opposite thing. One is to select, to put into my bag, and then the other is to select n minus r things to throw away, to leave it alone. Is that okay? So that's why these two counting should have the same value. Okay? Because when you are thinking of a case here, you have a corresponding case here. And similarly, if you have a corresponding case here, you have a if you have a case here, then you have a corresponding case here. Is that okay? Is that okay? Good. So far, we still do not know any formula. So even though we don't have any formula about this CNR, we still know that this equality always holds. Is that okay? Okay? Let me give you another one. How about this one? PNR. So this is about how many ways to select R things and then to arrange. And then I'm claiming that this is equal to CNR times PRR. So why is it true? So I don't have any formula for anything yet, but I'm claiming that, okay, so they're always equal, okay. PNR. You select R things and then you arrange them. It must be equal to CNR times PRR. Why? Okay, this is very simple. Rule of product. If you want to find a particular arrangement here, what do you need to do? A particular arrangement here is you first select R objects and then arrange. Is that okay? So the number of ways of doing this must be equal to the number of ways to select R objects times the number of ways to arrange R objects from R objects. Is that okay? So this is by rule of product. Is that okay? Okay. And finally, this one. How about PNN? PNN is equal to, this one is interesting. So this is PNR multiplied with P n minus R n minus R. So I have n items. I want to make arrangement to it. So there are n items. I want to make arrangement to it. Oh, okay. So what is meant by arrangement? Let's say there are n items. So there are n items. So there are n items here. An arrangement is to put this item into a line from left to right. Okay, so maybe this is A, this is B, this is C, this is D, this is E, this is F, this is G, and this is H. Maybe I want to put B here, and then put D here, put E here, put A here, and so on and so forth. Okay, this is the way that we can form an n permutation. So PNN counts how many n permutations that we can have, and then we are saying that this is equal to, exactly equal to, always equal to, PNR multiplied with Pn minus R, Pn minus R, Pn minus R, n minus R. So why is it true? Why is it true? Okay, good, good. So this is again what? Rule of product. Okay? So you want to arrange n things. Then what you need to do, okay, so you can think of this as separate the process. Like you're very lazy. You want to arrange n things, but you want to separate it into, you want to do this in 2 days. Okay, so in the first day, you want to make the arrangement of the first R items. And then in the second day, you want to make the arrangement of the remaining n minus R items. Is that okay? So what you need to do in the first day is choose R items and arrange them, put them into the first R slots. So this is the first day that you do. Okay, the first day you select R items and make arrangement here. And then, this is not done yet. To complete the whole process, you need the second day. So in the second day, there are going to be, okay, let's say R is like this. In the second day, you have n minus R items left here, and then you want to put them here. So there are Pn minus R, n minus R ways. Okay, so this is again rule of product. To do a whole job of putting n things into these slots, you separate it into 2 parts. Put the R items first, and then put the n minus R items later. Okay, but then there is something different here is when you put the R items, you have n items that you can select. So there are PNR ways. But once the R items are gone, there are only n minus R items left. Is that okay? And then you put all these n minus R items in the remaining box. Is that okay? You can actually make this even more complicated. If you believe this is true, you can do the job in 3 days. Okay, so this one is PNR. This one is Pn minus R K. You can have K, and then the last one is Pn minus R minus K, n minus R minus K. So this should give you the same value. Is that okay? Because you are chopping the job into 3 parts. Okay? Is that okay? Good. So far, we don't have any formula yet, but we can now derive the formulas based on these things so that we can later use that handily. Okay, so let's derive a formula for PNR. Okay, let's do a formula for PNR. Okay, so first of all, let's take a look of what is PNN. PNN, so on that side, we are saying that this is equal to PNR, P n minus 1, R, n minus R. Am I correct? And then this is true for all R. So in that sense, let's try R is equal to 1. Let's see what will be the effect. So when R is equal to 1, we will have Pnn is equal to Pn1 times Pn minus 1 n minus 1. Is that okay? Is that okay? And then Pn1 is equal to what? Pn1. How many ways to select one thing and then make an arrangement if there are n items? How many ways? N. Very good. So it is equal to n times P n minus 1 n minus 1. Is that okay? And if you believe this format, so this is like another Pnn. Am I correct? So this will be equal to, so if you try to expand this one using the same formula, then this should give you, so I keep the n, but then this one will give me n minus 1 times P n minus 2 n minus 2. Is that okay? So I'm using the same formula, but on Pn minus 1, Pn minus 1. Because Pn minus 1, n minus 1 is equal to Pn minus 1 choose 1 times this term. Is that okay? Okay? So if you believe the formula, so this will be equal to n and then n minus 1 and then n minus 2 and so on and so forth up to 2 times P11. Is that okay? So what is P11? P11 is how many ways to select one item from one item and then arrange. That's one way. Very good. So this one is equal to n factorial. Okay. Is that okay? So Pnn is equal to n factorial. Okay?